In this video, we're going to talk about the first derivative test. So the first derivative test is a way to allow us to find algebraically where a function has max, mins, and is increasing or decreasing without graphing it. Okay. And it allows us to find the extremas. So how we're going to do this is we're going to use the whole idea that extrema, max and mins, occur at critical points or endpoints. And so to find the extrema and the increasing, decreasing intervals with the first derivative test, what we're going to do is we're going to first find the critical values by setting the derivative equal to 0 and solving. And then we're going to make a sign chart. And then that sign chart is going to help us see where the derivative is positive and where is it's negative. And then we know that if our derivative changes from positive to negative, our critical point is a max. If it changes from negative to positive, our critical point is a min. And if it does not change, then there's no local extrema. And again, it's called a plateau point. Okay, so let's do an example. So we're going to find the extrema of x squared minus 2x. And we actually found the critical values before. Okay, but step one is set f prime of x equal to 0 and solve. So find, again, that's called the critical values. So we take the derivative, which is 2x minus 2, and set it equal to 0. Solve, and we get x equals 1. Okay, step 2 is to make a sign chart. Now, for these, I often use the number line method for the sign chart because I think it's faster. But you can draw your sign chart whichever way you want. You just need to make sure you're showing the relationship between the derivative and the original function. So on my number line, I put 1. And then what I'm going to do is to make the sign chart, I have to know what's happening with the derivative. So I need to know, is the derivative positive or is it negative? And that will help me figure out if f is increasing or decreasing and whether I have a max or min. So we are going to use our derivative, which is 2x minus 2. And we know that the derivative is equal to 0 at 1. So I'm going to put 0 for the derivative. And so before 1, my derivative either has to be positive or negative. Okay, it can't be 0 because the only place it's 0 is that x equals 1. So what I'm going to do is I'm going to pick any number in this interval. So again, this interval is from negative infinity to 1. And I'm going to pick any number in that interval and do what's called a test point. And I'm going to plug that test point into the derivative to figure out if it's positive or negative. So the test point up here, point I would use if it is in the interval is I'm going to use 0 because 0 is usually very easy to find it. And I'm going to find the derivative when x is 0. So I'm going to do 2 times 0 minus 2, which is negative 2. Okay, and all I need is the sign. I don't really need the value. I just need to know, okay, it's negative. And so I'm going to put negative for f of x, for f prime, and then that means f is decreasing. Okay, and so I know from negative infinity to 1, my derivative is decreasing. Okay. So my second interval is from 1 to infinity, and I need a test point in that. Okay, so the test point that I'm going to use there is any number greater than 1. So let's just use 2. And I'm going to plug 2 into my derivative. So I have 2 times 2 minus 2. And again, all I really care is the sign, but it's a positive 2. And so I'm going to put a positive for this interval. And that means my function is increasing. Now, these test points are not values that I use to describe the function, are not the key critical values. They're just values I plug into the derivative to see if it's positive or negative. And I can pick any number in this interval. So I could have picked -1 or -10 or -100. I could pick any number greater than 1 for when I did this interval. And so now that I know that, I can see when I draw my graph, okay, my graph is decreasing and then increasing. And so that makes f at x equals 1 a min. And again, if you don't like that way, you can also do it this way. And sometimes with the first derivative point, they add a column for test point. So I'll do it this way too, f prime f. So my intervals are negative infinity to -1, -1, 1 to infinity. Okay, my test point, I pick something in this interval. So again, I'm going to put, I don't know why I put -1, +1. Okay, so I'm going to pick 0. Then I find f prime of 0, which I did up here, which is -2. So it's negative and my function is decreasing. From 1 to infinity, my test point I would pick is like 2. F prime is positive because I found it here. It's 0 at 1. And so here F is increasing. So again, you can put an arrow or can put increasing. I think just the arrows help you visualize what's happening. And then because I'm decreasing, then increasing, this is a min. We don't put a test point for the critical value because that's where the interval changes. So there's nothing to test. So this is the other way to draw the sign chart, and then you'll have to answer questions. So it says find the extrema for this one. So the extrema would be a minimum at x equals 1, and we often want the point. Okay, so I have the x value. If I need the point, I need to find the y value. To find the y value, I use the original function. So I'm going to find f of 1 to get the y value of this function. And that was x, the original function was x squared minus 2x. And so I'm going to find 1 squared minus 2 times 1. And that gives me -1. And so my extrema, my relative min, is at 1, -1. And then they might also ask you, like, where is f increasing and where is f decreasing? So we would say f is increasing from negative infinity to 1. Okay, so on this interval. And f is decreasing from 1 to infinity. So that's kind of the basics of the first derivative test. And then I'll have a few more videos with more examples.